Hi, I'm Lisa Gillespie, craniosacral therapist. Today I'm going to be giving you a tour of the cranium. This is designed to give you a better sense of the structures, the anatomy that is underneath your hands when you are holding a cranium. The better you understand the anatomy, the more specific you are able to be with your focus, and the more in-depth conversations you're able to have with the body. So let's get started. Give you an overview. Here we are with the cranium. You're looking at the lateral aspect and the posterior aspect. Here I'll give you the superior aspect, and we'll look at the details of this in just one second, and then the underside. So just to help you get oriented to where we're going to be exploring. All right, we're going to start off with the frontal bone. The blue bone here is the frontal bone, and I really want you to get a sense of the depth of the frontal bone, especially what I'm referring to is the roof of the orbits. So the frontal bone makes up the roof of the orbits, and it also makes up the floor that the frontal lobe, the anterior part of the frontal lobe of the cortex, rests on the floor of the frontal bone above the orbit. So you've got this shelf here, and on the underside of the shelf, you've got the eyeballs, and above the shelf, resting on it, is the frontal lobe of the brain. To give you a side view so you can see a little more the depth that is present there. So the frontal bone articulates with the green parietal bones at the coronal suture. So we have the coronal suture present there. It also articulates anteriorly with the nasal bones, left and right nasal bones, with the left and right maxilla. And if you look a little bit further behind the maxilla, you'll see the yellow bone. That is the lacrimal bone. There are two lacrimal bones, left and right lacrimal bones. And then behind the lacrimal bones, so posterior to the lacrimal bones, you have the white bone there that is the ethmoid. And the ethmoid is a single bone. It makes up the medial wall of the orbits. And we'll be looking at that more in depth as an individual bone, so you'll get a better sense of how it all fits together. The frontal bone also articulates at the lateral edge of the orbit with the zygoma and with the greater wing of the sphenoid, which you'll have a better sense of when we look at the sphenoid again as an individual bone, but just to give you an overview here. And then, as I mentioned, we've got the coronal suture where it articulates with the parietal bones, left and right parietal bones. The frontal bone houses sinuses, so it has air sinuses present in the frontal bone. If you've ever had a sinus infection or been congested, allergies, that sort of thing, you're probably really familiar with what it feels like to have a congested frontal sinus. But the location of it is approximately here. Now, apparently, it's not present in everyone. I'm not sure exactly what the percentage is, but I find that curious. The sinuses are really designed to offer resonance to the voice, which is why our voices sound so different when we are congested. Now, I want to show you a disarticulated frontal bone so you can get another perspective of it. So here we're looking again at the frontal bone, and you can see a couple of things here that I want to point out to you. Number one, the depth of that shelf that we talked about, that makes up the roof of the orbits and the floor for the frontal lobe. And the other thing I want to point out to you is the ethmoid notch. And that notch there is where the ethmoid bone fits up inside. And we'll take a closer look at how they meet when we take a look at the ethmoid. But you can see there against the black background a little more clearly that notch that the ethmoid fits into. You may also notice this line down the front of the frontal bone, down the midline of it. This line is a remnant of the metopic suture. And at birth, the frontal bone is still in two parts. It doesn't finish knitting together until approximately ages 7 to 8. So that's a lot of time for that frontal bone to have acquired adventures that will certainly impact how it meets the different bones that it articulates with. The chances of you finding a frontal bone that is completely symmetrical are pretty much slim to none. I also want to show you the inside of the frontal bone, and I'm going to use my finger here to demonstrate the depth. So I am, there you can see nicely, I am up to my second knuckle on the finger in terms of the depth of that frontal bone. You can also see on the inside this ridge here, and that ridge is where the fulx, the membrane that divides the left and right hemispheres of the cerebral cortex, that fulx runs down the midline of the frontal bone. It actually peels off the periosteum in those areas, peels off and forms two layers, which forms the fulx. And we'll talk about that more in depth with the membrane video. So that gives you a nice sense of the contours and the shape of the frontal bone. Now let's take a look at the ethmoid bone more in depth. So we talked about the ethmoid notch where in the frontal bone where the ethmoid sits in. Here we have the ethmoid. It looks a little bit like a peach pit. It's got all those different nooks and crannies present in it. Now, let me orient you here. You are looking down on the top of the ethmoid. So here is the ethmoid sitting inside the head. This would be where the frontal bone is. So the front of someone's face, you're looking at the side. Now you're looking at them head on, so they're facing you. And now you're going to look down on the surface of it. And what you're seeing here is the cribiform plate. And the cribiform plate is formed of, you can see these little holes in the cribiform plate. They're called olfactory foramina. And the olfactory nerve sits on either side of the crista galli, and the crista galli is this projection. There we go. So you can see this projection sticks up. That's the crista galli. The crista galli, as you may recall, is where the fulx anchors anteriorly. So the fulx, that membrane, horizontal membrane dividing left and right hemispheres of the cortex, anchors on the crista galli. And on either side of the crista galli sits the olfactory nerve. And those branches, those fibers of the olfactory nerve run through the olfactory foramen, and they pick up the molecules that are being inhaled, and then they convey that information from the nasal cavity to the brain. Interesting factoid for anatomy geeks. The olfactory nerve bypasses the thalamus, and the thalamus is typically where all sensory information has to pass through before the thalamus then decides where it gets, what gets sent to the cortex and where it gets sent. So the thalamus is this relay station that decides what goes where and where it should go. The olfactory nerve actually bypasses the thalamus and goes direct to the cortex. It does interact with the thalamus later on, but not initially. It's the only sensory information that bypasses the thalamus initially and goes straight to the cortex. You might also notice, we're looking at the posterior aspect of the ethmoid. You can notice a little cavity present in the back of the ethmoid. This is actually where the ethmoid articulates with the sphenoid, and we'll look at that in more detail, that articulation. But that cavity is the ethmoid sinus. So just like the frontal bone, the ethmoid also has a sinus present in it. Now, the other thing I want to point out to you on the underside of the ethmoid is the perpendicular plate. So you've got a plate that runs up and down, conveniently, logically named. And that perpendicular plate actually articulates with the vomer, which is a really thin, rudder-like shaped bone. There you can see the perpendicular plate more clearly. And as I said, that's what articulates with the vomer.